This conference will.
Let's have a look at what we will do today. Our intention is to show you how you can reduce complexity in your software, because it's the complexity in the software that leads eventually to difficulties in maintaining the software and gives it a shorter lifespan. Complexity in the software also leads to unnecessary testing or difficulties in testing or impossibilities in testing. For instance, if you have circular dependencies in your architecture. And testing we want to do, all my customers today are including a lot of testing into their continuous integration, continuous delivery, build environment. And they are also concerned about build times. So for those that have real big projects, build times is becoming a big concern. And the more complexity you have in your software, the more time it will take to build. It will take more time to run static analysis, etc. So if we can reduce complexity in our software, that will help us with all these things. And complexity, yeah, it's hard to understand software architecture when you're getting like thousands of classes, thousands of functions into your software. This picture shows only about 35 software entities and how they're represented in a block arrow diagram. And in this diagram, as you can see, it's really hard to understand what dependencies are good dependencies, what is the actual architecture here. It was probably not drawn like this originally by the software architect, but this is how a tool will interpret an architecture as it is. A couple of years ago, I ran into this technology with matrices representation. So software leads very well into be represented by a matrix format where you can represent the various entities being classes, being a module level, or packet level or whatever, and you can organize and sort that information into matrix. And there is really beauty in this. And that is that by using this type of representation, you can use also a mathematical algorithm to sort the information so it become meaningful. Because if you have thousands of classes represented in a matrix, it can be just as confusing as the block diagram. But by organizing it, by sorting the information in layers automatically, we can get a very good understanding of our software. We can immediately see when we are getting bad dependencies into our software. And this can also lead to better understanding of things like how much software have we tested? How is our build process proceeding? And all that I will leave to you, Sean, to more show us in more detail. I just want to point out one final thing before I leave it to you, Sean, and that is about questions. We have a chat window. Excuse me. Use the chat window to enter any questions you have, and we'll try to answer them either on the fly or at the Q&A session at the end of this webinar. Planning to go on for about 45 minutes. So now, see if I can make you presenter.
Okay. Thank you, Michael. That was a great introduction. Okay. Can you see my screen?
Yes.
Okay. Yeah, just before I start, I just want to add that Frank Waldman is also on the call with me from Lattix. He's one of the founders of Lattix, and he can add some color to my presentation as well. So, Frank, I don't know if you're unmuted, if you want to say anything.
Yeah, thanks, John. Yeah, I'm happy to be here and glad to see such a great turnout for this webinar.
Yeah, awesome. Okay, great. So, my screen, I'll just start from the top. So we at Lattix, we're a US-based company. We have resellers all over the world, and we're very happy that Michael with Know-How is handling Scandinavian countries. I think we've had a long, great relationship between the two companies, and it's great. So what Lattix is, what we do, we focus on analyzing your software architecture. There's a lot of tools out there that do other parts of your software. There's Cantata for testing, the static analysis solutions like Clockwork, Exhibian, Coverity, things like that do focus on the quality, but we focus specifically on your software architecture. And specifically, we help you first understand what your current architecture is, and then we define it or help you refactor it and then control it. And if I just go to this next slide, what is Lattix Architect? As I said, we help you understand what your current architecture is. A lot of times you'll have an architecture at the beginning of a project, or you've, in your mind, you kind of understand what the architecture is, but without actually having a view of it, you don't know what its current state is. And that's the first benefit of Lattix is we analyze what your software is today, what your current source code looks like, and give you a picture of your architecture. So you can compare it to what you think it is, or what the original document is. And a lot of times with our customers, we'll see that it's diverged from that. There's been software architectural erosion, which we talk about. And so things, as Michael was saying, that leads to slower build times, unnecessary testing, and just general complexity in the software, because you're thinking it's working a certain way, and there's impact or dependencies that you don't expect. That and we've all seen this, is if we've changed a line of code and then something breaks that we didn't expect it to break, or something stops working that we just didn't expect, and that's because there's a dependency somewhere that you didn't realize was there. And now with Lattix, you can go in and see very easily if there's other dependencies there. So that's understanding the software architecture. The second one is defining or refactoring. So if you do, this happens a lot. We'll show people their current architecture, and they say, well, okay, we got to refactor this, or we got to do something with this. Or people will come to us and say, I want to improve my test coverage, or reduce build time, and so I'm going to undergo a refactoring project. And Lattix allows you to edit the dependencies, which I'll show you in a few minutes, and you can do this what-if analysis, so you can plan out what your refactoring is going to be. So you can say, well, if I change this, will that improve the modularity? Will that get me back to my original architecture, or an architecture that I want? A lot of times people will come to us and say, I want to go to the cloud. I want to do microservices. I want to, I have a application. We're working with a company right now where they have, for the last 10 years, everything's been on a single core, and now they want to go to a multi-core architecture. And so we're helping them break up their software into components so they can run it on multiple cores, which is happening more and more in the industry. So those are the types of things we can help with, and we actually do services around this as well. So we've helped companies, go in and help with the refactoring, because we have a lot of people on staff, who do this on a regular basis. So, and the final piece is the control or monitor the software architecture. So, Michael was talking about you're checking the software architecture during a CI DevOps process. And this is, I really feel this is where we provide the most value, is you can understand where your current architecture is, you can help refactor it, or you can refactor it. But the problem is if you get it into a nice state, tomorrow developers might come in and change it again and add dependencies, bad dependencies where they're not supposed to be. And there's no way of checking that. You know, it's up until Lattix, you know, just hasn't been a way to do that. You know, if you, with your software quality, you can always run a static analysis solution over it and get your violations. You know, with testing, with Cantata, you can run your unit tests and make sure that you haven't broken anything. But it's hard to understand, have you broken your architecture? And that's where we come in with what we call design rules, which help you define and enforce your architectural design. So you can go in and quickly make design rules in Lattix and then run it as part of a CI DevOps pipeline. And each time you run it, or each time you run a build, you can see if you've made, if there have been any violations to your architecture. Very similar to what you do with a static analysis solution, where you'd have, you know, violations to your actual source code, or unit testing with something like Cantata, where you run the unit tests and you know immediately, oh, one of my unit tests failed, so I got to go in and fix that. Well, if you run Lattix as part of your CI DevOps pipeline, you'll quickly know, oh, I had an architectural violation too. So, you know, I should flag that. I should maybe fix it, or, you know, go talk to the developer and see what's going on there. So you can quickly identify architectural flaws. You can see, you know, places where there's lots of complexity, and I'll show that to you in the in Lattix Architect itself. So, you know, so just I'll go through this. I kind of went through this before just now, but you know, why Lattix? You know, architectural visualization. As Michael talked about, we have these special algorithms as part of this DSM technology that allows you to do architectural discovery. You know, what your architecture actually is. Metric visualization within our heat map. That's something new that we have if you've seen Lattix before. You know, refactoring. So, and you know, specifying the rules as I've talked about, and tracking, measuring, and you know, reporting the software. You know, tracking, measuring, and reporting on the architecture. So, and impact and risk analysis, as I was talking about, is you know, that's, I think, one of the big things is you can't, you know, if you don't know what your dependencies are between things, you can't understand what the impact or risk of making a change would be. You know, so you don't know, if you change a piece of software, what am I going to have to go test? You know, what are all the things that need to be tested there? You know, so you could be doing unnecessary testing. You know, as Michael was talking about at the top, you know, you don't want to do, you want to avoid unnecessary testing. If you know, if you're going to fail your software, you want to fail it as quickly as possible. So, you know, there's this concept in software development right now of shifting everything left. You know, putting everything closer to the desktop. So, and it's all about failing quick. You know, so if you're going to fail, you don't want to find out 24 hours later, 2 weeks later. You want to find out within an hour, within 15 minutes, you know, because then you can fix it. You remember what you did, you can make, and understanding the impact and understanding the risk of things, you know, really helps with that. You know, and the same thing if you're going to make a change, you know, and you have to deliver the software in a couple of days, you can look at the DSM and say, oh, this is going to impact a lot of the software. Maybe I don't want to make this change before we release, you know, because there's going to be a lot of risk to this. So you can look at the DSM very quickly and see that. And I'll show that in the software, in the Lattix itself. So just, you know, I'll go through this again real quickly. The complexity, you know, one of the things that Michael was talking about in his slides is reducing complexity and avoiding software erosion. You know, in Lattix, we find that software erosion leads to software complexity. So if no one creates their architecture from the beginning and says, I'm going to make this as complex as possible. You know, everybody says, you know, we're going to make it modular, we're going to make it understandable. So you know, so hopefully software development will work, will be smooth all the way through. Unfortunately, I think we all know that doesn't necessarily happen, and a lot of times that's because of software erosion. So you're adding dependencies to your software that violate your intended architecture. That's the software erosion and the software architectural erosion. And if you're going to add to the complexity of the software, in many cases you can reduce that with modularity. So a modular system is easier to build, easier to test, easier to maintain, and at a lower cost because you know what your impact is going to be. There's not going to be unintended issues. You're not going to change something in your code and then have something you never expected break, because you understand all the dependencies. You understand what's happening with the system. So that's when we talk about complexity, and through dependencies, that's what we're talking about is all these bad dependencies that unfortunately slip into the system because of software erosion. Michael showed this slide. Just to introduce Lattix is typically when we think of an architectural diagram of software architecture, we think of something like this. The problem with this is it doesn't scale. It's hard to understand if you have bad dependencies, even what the architecture is here. It's very hard. This is, as Michael was saying, this is a very small version of Lattix. I mean, of a software architecture. We've seen huge balls of architectures in it, and it's just hard to understand what's going on here. Are there bad dependencies? Is this the way it's supposed to be? So it's just not easy to understand, and that's where we came up with, Frank and our other founder, Niraj Sehgal, came up with this idea of, or adapted this idea of a dependency structure matrix to software. This is dependency structure matrix has always been around for system engineering, so complex manufacturing processes and other complex systems. And Frank and Niraj decided, well, software is a complex system as well, so we can apply this to that. And I think it's really worked really well, because it is scalable, and you can visualize dependencies, and you can see where there's issues very very quickly, especially with the algorithms and things like that. So that's what I'm going to show today, and just a little picture of, as I said, our heat map, where you can. Then this is something new that we've created in the last 6 months. Is you can visualize your issues and metrics against the architecture, which is very interesting because you can see, if you've made changes or you have violations, MISRA violations, which parts of the software are those violations affecting, and where should I focus to make changes or add to that. So so I'm right now I'm going to go to Lattix, and I saw a question in there about which languages we support. So we support C, C++, Java, C#, Python, Ada, JavaScript. Frank, did I miss any? I think that was most of them. I said C#. Yeah. So it's on our website, but we support most languages, and we can support other languages as well. That's not a problem. This is a C++ project here. This is ISO AGLib, which is an open source project, embedded open source project, and we typically use this just because it's kind of easy to use, and unfortunately it doesn't have a great architecture. So a dependency structure matrix, this is a kind of heart and soul of Lattix, is a simple, compact and visual representation of your software architecture. So compared to a map of the software architecture that we saw in the diagram, this is a much easier way to see this. So this figure here, for this embedded software application, is decomposed into 6 subsystems. We have COM, schedulers, HAL, driver, util, and star. And these subsystems were discovered using the directory structure on the project. So we do, there's a couple different ways that you can add, you can bring your software in. You can just point Lattix at your software, and we can do, go through the directory structure. You know, if you're using something like SciTools Understand or static analysis solution like Clockwork or Xivian, we can import that data in, but we need to do some sort of static analysis or parsing of your source code to find the dependencies. And that's what we've done here is and we use the directory structure by default to understand that. And the just to clarify on what a dependency structure matrix is, the X and Y axis here are the same. It's a matrix. It's always going to be a square matrix, and they're numbered sequentially. And the dependencies for each subsystem are read down a column. So if we're reading down column 1 here, we see that star here depends on HAL with a strength of 4. And the information on these dependencies can be found in our information panel. So you can see what those 4 dependencies are, and you can see you can go right to the line of code. So if you want to know what those dependencies actually are, you can go in and hook this up with your IDE or VI or whatever you're using for to look at your source code. And then you can, the next part of this is that you can see that the subsystems are ordered alphabetically by default. And one of the benefits, as I was talking about, of the DSM is you can apply algorithms to the matrix to figure out what the architecture is. And this is called partitioning, and which we do to order the system by usage. So with software, we typically use the component partitioning, which puts the utilities, the things that are more heavily used, at the bottom of the architecture, and the application code at the top. So if I apply the partitioning, I'm going to go down and I'm going to apply this recursively so that everything gets applied. I'm going to see that, and you can see that COM has gone to the top of the hierarchy, which we'd expect. That's a communication layer, and util and HAL and driver have moved to the bottom because they're which we expect because they're being used by a lot of things. So that's one way to kind of figure out what the architecture is. So this is what your stack is for your software in your current architecture. It may look different in what you had intended your software to look like. You may not have intended there to be a util layer here, but there is. And so it's the insight you're getting here is, what does my architecture look like today? And that's kind of very hard just to look at the source code and figure out what the architecture is. You can do it. It's just not an easy thing to do. And so the other benefit of Lattix is the way we represent the hierarchy of the software. So if I expand the one of these out, you can see that we can go all the way down. Here we are at the file level, and we can go inside the file level, and we can get right down to the members of a file or class. So we can get the variable names, we can get the functions, we can get the individual classes if you're doing C++ or Java or something like that. And so you can get right down to the individual level, and that's one of the big benefits of the software is you can get right down to understand what's going on in terms of the software. In terms of testing insights, as Michael had pointed out, and I talked about a little bit, you can understand the impact of making a change to the software. So for example, impl here is what we call a change propagator. So it depends on a lot of things, and a lot of things are depending on it. So so this is some place that you'd really want to check out and make sure that you have good testing for this piece of the software. Or if you're just starting with something like Cantata or something like that, this is a good place to start. This is a good place to start putting unit tests in. Is something like impl or part 5 network management, because you can see there's lots of dependencies here. And that means that if you make a change to one of these, you're going to impact a lot of things. And there's a lot of places that could be broken. And that's just one of the quick insights that you can get from Lattix. The next part, that's kind of understanding what your current architecture is. The next part is sort of our what if analysis. So, what if you now see that I want to make some changes to the software. I want to refactor it and see if I can do different things. So, I know that COM is supposed to be its own module, but it isn't, because we have these dependencies that are going back up the, so COM is in a cycle with driver, because COM has dependencies to driver, and driver has dependencies to COM. So it's in a cycle. Same thing with util. So what if I go in and I decide to hide these dependencies just to see what's going on? It tells me what those dependencies are, and I just say hide those, and it actually puts those into a work list. So if you do actually want to go and make the changes to the code, you can do that. It'll tell you exactly what you need to go and change. So if I go in and break these cycles and see, okay, what's this going to do? What's the change going to make here? So I'll go in and reapply the partitioning, and you can see, oh, all of a sudden COM is its own module, which is the way the architecture was supposed to be. COM is supposed to be its own thing, and so maybe this is a refactoring change you want to make. So you can go in there and see this, and now you can the testing will be easier on COM, because you don't have these cycles. So if you're making a change, it's not going to affect these other parts of the system, and you can build it and test it independently, which is really nice. But if you didn't want to make this change, I mean, it's just like Word or something like that. We have a back button, so you can go in and as I said, you can do this what if analysis and decide if you want to make this change or kind of what you want to do. So it's really helpful, like I said, for refactoring is you can plan out what you're going to do for the refactoring before you go in and do it, and see if you can get the architecture back to where you want it to be. So the final thing, piece of this, I showed you understanding the architecture, refactoring or defining what your architecture you want it to be, and the final piece, is this concept of design rules, which allow you to monitor or enforce your architecture over time. And a lot of times we do this in a CI DevOps pipeline, which we highly recommend. So if we look at COM again, now we know we want this to be its own module. So if I go in and add rules, so I say we don't want dependencies there. We don't want dependencies to driver. According to the architecture, we want this all to be its own module. So cannot use and cannot use, and you can see these red triangles are violations. So the yellow triangles are the rules, and the red triangles are the violations. So you can see you have 2 violations right off the bat. And so if we remove these, we remove those violations. Just like I was talking about, this is kind of like static analysis, where you see what your architectural violations are, which is really nice. And then if you can run this again, in your next build, you can load the next version of the software into Lattix, or run it, as I said, on a CI DevOps pipeline, and see what those have you broken the architecture again? Is it going to did I add more bad dependencies? Are there new violations to the software? Which is kind of a really powerful thing. Is not only are you understanding the software and possibly refactoring it, but you're monitoring it over time, so am I adding architectural technical debt to the software? And that's really powerful in terms of constantly monitoring it. A lot of times you just don't know what your architecture is doing, and is it getting worse? Is it getting better? This way you have an understanding of that. You'll get that insight into the software. And as I said, we've done a lot of, and again, we have a services partner called Code Clinic that does a lot of pipelines for companies, and helps with CI DevOps pipelines, and they implement Lattix as kind of the core of their pipelines, just because it helps you understand what your architecture is doing, and that affects your builds, it affects your testing, and you know, things like that. So those are kind of the three parts: understanding your current architecture, defining what your architecture is going to do, and then understanding the design rules. So as I said, you know, we put this into a pipeline. You know, so this is kind of the pipeline with Lattix at the center. You know, a lot of times we use Cantata as for unit testing, and we like, or I guess Code Clinic likes to put this into a GitLab pipeline. You know, but we've done it for Jenkins, we've done it for a lot of different CI DevOps tools. But you know, you build the software, you run your static analysis solution over it, which can be any static analysis solution, and then you run Lattix as your architectural analysis, and then you run Cantata or you know, another unit testing tool as your unit testing, and et cetera. You know, if you do security analysis, you can use, you know, something like white source or other things, and then, you know, your quality gates and that sort of stuff, whatever you're using for that. But we really see Lattix as the center of a CI pipeline, just because it can help improve the build time, it can help improve testing in terms of code coverage, things like that. And it's with this whole trend of CI and DevOps, I think it's helpful to understand your architecture. Is becoming more and more important. You know, a lot of people are using static analysis solutions, so they're understanding the quality of their software. They're using unit testing tools. You know, so again, they're improving the quality with things like Cantata. And the next generation, I think, is architectural analysis. Is, you know, now that you've kind of got quality under control, hopefully, how can I speed things up? How can I improve my test coverage? Things like that. And that all comes back to architecture. And that's really what, you know, some of the things that Lattix can help with. So, so that was just a kind of a quick overview of Lattix. Frank, did I miss anything? Did you have anything to add to that?
Thanks, John. No, I think it's the important thing is to really understand how you might be able to incorporate Lattix earlier in your continuous development. So all of this information can be presented in the merge request. So before you merge back into your dev or master branches, you have made sure that you haven't regressed the quality. So having that data visible really does make a tremendous difference. The other thing I'd like to mention is we also have worked for embedded systems. We've worked quite closely with the folks at JFrog that do Conan, which is a great way to repackage the software. So so you don't have to rebuild what doesn't need to be rebuilt. If you create packages that are binaries that, you know, that don't have to be changed, and so the build times can be reduced dramatically. We're working on a project now where the goal is to go from a 17-hour build to a 2-hour build, and that's what really enables continuous integration. The other aspect is in compliance. Lattix has been doing a fair amount of work with ISO 26262 and DO 178C compliance, where it's necessary to define the architecture and modules and test for data and control coupling for those dependencies which cross global dependencies which cross module boundaries. And part of the pipeline, which isn't shown here, is a doc ops stage where the compliance reports are created automatically. So if you introduce a change in your feature branch, that can produce all of the artifacts that are necessary to maintain your compliance. And this is a technique that we developed with an automotive customer, which has been formally approved by the TÜV. and and so it's yeah, it's really something powerful. That's a new capability that we've developed in partnership um, with Code Clinic.
And we can, you know, if that's, you know, as Frank said, we don't I don't have the ability to show that today, but if that's something of interest, you know, we can certainly work. We can show you a demonstration of that. You know, just work with Michael and set up a time, and we'd be happy to show you. You know, we can show you kind of the whole pipeline working together. I know one of the questions was, you know, are we using this ourselves for our own development? And we do eat our own dog food. We have a GitLab pipeline that we run nightly, and you know, so we're running static analysis, we're running Lattix, obviously, and we're running unit tests every night, and we can go in and see the results all in one place, so we know quickly, you know, what's going on. So and we put that into you know, our own quality gate, which we call Lattix Web, which is another part that I didn't show. There's 3 parts to Lattix. There's Lattix Architect, which is a desktop product, which I showed. The command line, which allows you to do this pipeline, so you can run everything that you'd run in Lattix Architect on the command line. So you can, it's all DevOps CI enabled, so you can run anything you want. And then Lattix Web, which is a dashboard, you know, which allows you to see development over, you know, how things are trending over time. So, yeah. Okay. Did you have anything else, Frank? I didn't have any other.
Well, Michael has suggested that I show an example of the pipeline.
Okay.
So if we can make me the presenter.
Sure.
I don't know.
Yeah, I think
somebody could do that. Great.
Yeah, you should be
All
there.
right. Okay, great. Yeah, so if you can see my screen here, this is an actual file in GitLab. So I'm just showing it in the IDE that comes with the web IDE that comes with GitLab. So you can view the source code. In this case, we took a file down in the util directory, which we know everything is using, so you know it would produce some impact. And we made changes to it. So we added a bad dependency, and we broke some unit tests, and we created a new function that introduced a bunch of standards violations. And so once we create the merge request, and I don't have time to build the whole thing, so I'll just show you an existing merge request. When the pipeline triggers, so first, as Sean showed, we have the build, then we do the static analysis, and then the unit testing. We have the architecture analysis, which not only does it test for any violations, but it also generates metrics, creates the DSM and a heat map, and conducts impact analysis on any changes that have happened. And then it's all consolidated, so we can show all the metrics from the other tools in the tool chain in the heat map, and then we can complete the pipeline. Here you can see that we include and we automatically generate in the merge request the DSM. This is ISO AGlib, which Sean showed, and you'll see that we introduced a new defect here from this this util funcs up to the task controller client in the COM layer. And so this is just a nice visual. The heat map, which Sean showed, is automatically generated as well. And in this case, we've just added some unit tests for util-func, which we then subsequently broke. The thresholds here are for for coverage and complexity. We also introduced some AutoSAR violations, and so you can see that in the heat map. And then finally, we do an impact analysis, which is a report that goes into the compliance report to show that, in fact, we have actually tested everything. In this pipeline, we reduced the code coverage because we introduced a new function and we didn't introduce new unit tests to cover that new code. In terms of the code quality, in this case, we picked up a bunch of AutoSAR violations, and then we also found this new bad dependency that was created here in Utilfuncs. So this is an example of the CI pipeline. We can do this, of course, for other languages. So we have a .NET pipeline, a Java pipeline. The Java pipeline that we developed, we use on Lattix itself. So we're continuously building Lattix and changing it. So we're on version 12.1.4. The product is now 17 years old. So, obviously it's undergone tremendous change. And thankfully, we have the DSM analysis to help us maintain our own architecture. All right, any questions on anything that I've shown?
Or anything in general. We're happy to answer any questions on Lattix or architectural analysis or. Michael, is there anything else that you think we should show?
A lot more things to show, I know that, but I think we have to leave that to another meeting. Our time is expiring.
Okay. Yeah, we're happy to, if anyone on the call is interested in seeing this in greater depth, we're absolutely happy to, give a demonstration with Michael's team, know-how, and show Lattix and pipeline, or answer any questions. Feel free to engage Michael and his team, and let us know how we can help.
Thank you, Sean and Frank. Very good. We've seen that this really can help teams working with functional safety regulations to meet the requirements on documentation and verification of your processes. So just shoot questions to me at info@knowhow.se. Thank you everyone for attending. We have a series of webinars coming up, so keep your eyes open for those. We'll probably come back with a more in-depth presentation of how exactly to integrate Lattix into your CI pipeline. Thank you, gentlemen.
Okay.
Lattix.
All right, everyone.